Today's class is quantum electrodynamics. Now we have p square equal to p square c square plus m0 square c to the power 4. And in natural unit, we always feel that c is equal to 1. C is equal to 1. And also this equal to h square. And equal to then p square plus m square, and which is equal to alpha p cap plus beta of x. This is the direct. And E of pH, that is photon, equal to root over p square equal to p. So classically this is equal to p square by twice m. Now, what is the QED? QED is basically interacting theory between the Maxwell field, interacting theory between the Maxwell field mu and the Dirac field, psi bar. Now we construct the Lagrangian density, which is the three parts. Three part corresponds to the Dirac particle, three part corresponds to the photon particle, and interaction term between Dirac field and the electromagnetic field. And this LQED, equation of motion of the LQED, is del L of del A mu equal to del mu of del L by del of del mu A mu. Right. Now, all of you know that classical electromagnetic field equation, curl of E equal to minus del H del T, curl of H equal to del E del T plus J, where J is the current density, divergence of E equal to rho, and where divergence of H equal to 0, where H is the magnetic field. And also, all of you know that M mu, which is the field tensor, which is means that del mu A mu minus del mu A mu, which is equal to 0 Ex Ey Ez minus Ex minus Ey minus Ez 0 Bz minus By minus Bz 0 Bx By minus Bx 0. This is the field tensor. And for our notation, core current defined as J mu equal to rho of J and J of lower mu equal to rho of minus J, and current density. And mu for potential, mu means phi of A vector. And also the conservation theorem is del mu of A mu equal to J mu. These are the recapitulation of the electrodynamics. Now we construct Lagrangian. First, step 1. Construct Lagrangian. First, step 1. This L equal to minus 1 by 4 mu minus mu of J mu. Step 2, J mu to be a Dirac current. J mu to be Dirac current. And fermionic current harmonic current is psi bar gamma mu psi. Okay, harmonic or Dirac current is psi bar gamma mu of psi. That is the J mu is this psi bar gamma mu of psi. So therefore, L can be written as L electromagnetic plus L interaction, which is minus 1 by 4 mu nu minus E psi bar gamma mu of psi. That is J mu equal to E psi bar gamma mu psi. E psi bar gamma mu of psi. So L equal to E psi bar mu gamma mu of psi. So this can be written as minus 1 by 4 mu nu minus E psi bar A slash of psi. Okay, where psi bar equal to psi dagger of gamma 0 and psi dagger equal to also psi bar gamma 0, and psi bar whole dagger means that gamma 0 of psi. Step 3. Add to this the 3 Dirac Lagrangian LD. So L of QED can be written as L of EM plus L of Dirac Lagrangian plus L of interaction between them, electromagnetic field and the direct field. So therefore we can write psi bar I del slash minus m minus E a slash of psi minus 1 by 4 mu nu is the LQED, which is the Lagrangian of the LQED. Now we choose the gauge. Now we choose the gauge, which is actually Coulomb gauge. Divergence of A equal to 0. And also all of you know that divergence of E equal to rho, which is equal to E psi dagger of psi from the Dirac field, and E is equal to minus del A del T minus grad phi. So therefore, divergence of E equal to minus del A del T divergence of A minus grad square phi. Since Coulomb gauge provided us divergence of A equal to 0, so therefore this equal to minus grad square of phi. So therefore minus grad square phi equal to divergence of E, which is equal to rho equal to E psi dagger of psi. This is the value, and from this we also have that minus grad square phi equal to E psi dagger of psi, which is the one type of Poisson's equations with a negative sign. So the solution of phi xt equal to E by 4 pi integration dqx psi dagger of x prime t phi of xt divided by x minus x mod. So phi is expressible in terms of independent variable. Therefore, it is immaterial whether the conjugate momentum vanishes or not. Whether the conjugate momentum is vanishes or not. Now we construct Hamiltonian. First step one. First we determine the momentum, that is the conjugate momentum phi of psi which can be written as del L of QED by del of psi dot, which is equal to del of psi dot psi bar I gamma 0 del 0 of psi equal to psi bar I gamma 0, which means I psi dagger gamma 0 square, which means I of psi dagger, and all of you know that the phi of A from the quantization of the electromagnetic field, phi of A equal to, just all of you know that also we have from the quantization of the electromagnetic field, I of A equal to E. Since phi 0 of A equal to 0, that's why the vector sign. Step 2, construct Hamiltonian density H, which is equal to pi psi dot minus pi of A dot minus L. So this equal to I psi dagger psi dot minus plus E A dot minus psi bar I del slash minus E A slash minus M of psi plus 1 by 4 M mu mu M mu mu. So this equal to I psi dagger psi dot minus E A dot minus I psi dagger gamma 0 square del 0 of psi plus psi bar. This means del slash means that del mu gamma mu, which means del 0 gamma 0 minus grad of gamma. So from this we can write I psi dagger gamma 0 square del 0 psi, since psi bar equal to psi bar equal to psi dagger gamma 0, also psi bar equal to psi dagger gamma 0, that's why I psi dagger gamma 0 square del 0 psi plus psi bar of minus I gamma dot nebula plus E A slash plus M of psi plus 1 by 4 mu 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 mu. So this can be written as I psi dagger psi dot plus psi bar of minus I gamma dot nebula plus E A slash plus M of psi minus E of A dot minus I psi dagger psi dot minus half of E square minus H square. H field square, electric field square. So this term and this term cancel out. So this equal to psi bar minus I gamma bar plus E of A slash plus M of psi minus E of grad phi E of grad phi, since A dot equal to minus E minus grad phi and minus half of E square minus H square. So therefore Hamiltonian density H is equal to psi bar minus I gamma dot nebula plus E slash plus m of psi plus half of E square plus H square plus E dot grad phi. Now we evaluate the last term. Now we evaluate the last term of this love equation. Now first we derive dqx of E of grad phi. So this equal to, you can write dqx of grad of phi E minus phi of divergence of E. So first term is this equal to minus E of dqx of phi psi dagger of psi, since divergence of E, all of you know that we have E of psi dagger of psi. So this equal to this, and first term is cancel out since this is the surface term. So therefore the above equation can be written as HQED equal to psi bar minus I gamma bar plus E slash plus m of psi plus, sorry, this above equation written as, sorry, this can be written as psi bar of minus I gamma dot nebula plus m of psi plus psi bar E gamma 0 A0 of psi. This term is elaborately this, the second term. We can write elaborately in second term. Psi bar E gamma 0 A0 psi minus psi bar E gamma vector A vector of psi plus half of E square plus H square minus this term is E phi psi dagger of psi. Okay. So therefore HQED can be written as psi bar minus I gamma dot nebula plus m of psi plus half of E square plus H square, and this term can be written as psi bar E gamma 0 A0 of psi, since psi dagger equal to psi bar of gamma 0. So this term and this term is cancel out. So we can write this half square H square minus E psi bar gamma bar A of psi. So this term is actually Dirac Hamiltonian. This term is electromagnetic Hamiltonian. And this term is interaction between Dirac and photon and the Dirac particle. Interaction between the photon and the Dirac particles. This is called the, so this also written as HD plus H of EM plus H of interaction. This is called the HD, this is called HEM, and this is called H interaction. This is the Hamiltonian of the Hamiltonian of this system. Now the question is, now the question is, in the term of electromagnetic term, in each electromagnetic term, the Coulomb term is present or not, but actually the Coulomb term is hidden in the HEM term. Now we check it. So first we check. Now we have E is equal to minus del A del T minus grad phi, which can be written as Et plus El, where Et is the tangential electric field and El is the longitudinal electric field, and where this Et can be written as Et equal to minus del A del T, and so therefore divergence of Et equal to minus del A del T of grad of A from the Coulomb gauge. This can be 0, and El equal to minus grad phi. So therefore E square equal to Et square plus El square, which is equal to El square plus twice Et dot El. Now but we calculate d cube x of Et dot El, which is equal to minus d cube x. Et dot El means El means grad phi minus grad phi, so Et minus grad phi. So this can be written as minus d cube x of divergence of phi of Et minus phi of divergence of Et, right? So this term divergence of Et equal to 0, and this term is surface term, that's why 0. So this equal to 0. And we calculate half of d cube x of El square, which means that half of integration of dx El dot El. So this can be written as minus half of d cube x El of grad phi. So this can be written as minus half d cube x divergence of phi of El minus phi of divergence of El. So this term is the first term is the surface term, so that this is cancelled out, and second term equal to plus half of integration d cube x phi of divergence of El. Divergence of El. So this can also written as half of integration of dx phi into divergence of Et plus El, since divergence of Et is 0. Divergence of Et is equal to 0. So, therefore, half of d cube x El square means half of d cube x of phi of divergence of E. So this can be written as half of d cube x phi E psi dagger of psi. This is the value divergence of E. So we can write El square equal to E phi psi dagger of psi. So HQED can be written as, also can be written as HQED Hamiltonian equal to psi bar minus I gamma dot nebula plus M of psi plus half of Et square plus H square plus half of El square minus E psi bar gamma psi dot A. So this can written as psi bar minus I gamma dot nebula plus m of psi plus half of it square plus h square plus e by 2 phi into psi dagger of psi minus e psi bar gamma bar psi of a. So this term is actually hd Dirac Hamiltonian. This is the electromagnetic Hamiltonian. This is the H Coulomb, and this part is this is the H Coulomb, and this is the interaction term with with coupling strength E. So total interaction term is H Coulomb and this term, which is the total H interaction term. So therefore, H Coulomb equal to E by 2 phi of x psi dagger of x psi of x, which is equal to E by 2 E by 4 pi integration d cube x prime psi dagger of x prime t psi of x prime t psi dagger of x prime t psi of x t x minus x prime psi dagger of x t and psi of x prime t. This value is actually phi x. This is the electrostatic energy density. This is the electrostatic energy density. Now Feynman propagator. Already we derived the Feynman propagator of the real scalar field, Dirac field, and electromagnetic field. Now the symbol of this. So first, Dirac or fermion propagator is denoted by ISF of P, and symbolically or mathematically this can be written as I by P slash minus M plus I F star, and is symbolically denoted by this. Next, transverse photon propagator. This portion also we already derived I d of transverse TR nu. This can written as minus I g mu by k square plus I epsilon minus I of k nu minus theta dot k theta mu k nu theta nu k nu divided by k square plus I epsilon theta dot k whole square minus k square minus I of theta nu into k square whole divided by theta dot k whole square minus k square of k square plus I epsilon which denoted by this, and Coulomb propagator Coulomb propagator I of d Coulomb mu equal to I of eta mu whole divided by eta dot k whole square minus k square, and denoted by okay, and this term also written as I of eta mu by eta dot k whole square minus k square. This is then nearly equal to. So today's class is closed. Next day we talk about the Coulomb scattering. Next day we talk about the Coulomb scattering. Thank you all of you